This is a quick video for given, or given that. And usually it is written as probability of event 1 given just a straight line, event 2. So what does that actually mean? Well, if we have event 1 getting a 4, and event 2 getting an even, what's the probability of that? Well, I'm telling you that we got an even. So if we roll a dice, I always forget that, roll a die once, and I told you it was an even, what's the probability of it being a 4? Well, an even just means that it's either a 2, a 4, or a 6. So that's one outcome out of the possible 3 outcomes. So the probability of event 1 occurring, given that event 2 has occurred, is 1 out of 3. Now let's go down to cards. Let's have event 1 be getting a ace of diamonds, and event 2 be getting a red card. So what's the probability? Probability event 1 occurs given that event 2 has occurred. Well, if we were to draw a Venn diagram, we'd have our red area, red. So all the cards in here are red. Make that a little better. And then we'll have our little ace area, which represents getting the ace of hearts. So when I tell you that we pull out one card, pull one card, what's the probability of it being an ace of diamonds given that it's red? So all we want to know is the ratio of this area of the area of the ace of hearts. So area of ace of hearts, or ace of diamonds, sorry, divided by the total area of the red. So the area of the red. Well, that is just simply this area divided by that total area, or more simply put, that's one card out of 26 red cards. So this area, the red area, represents 26 red cards, and this little area represents just the one card. Now what you might see is the equations where probability of event 1 given event 2 has occurred is equal to the probability of intersection event 1, event 2, all over the probability of event 2. So what does this mean? Well, that's just this one little area. That's that one area. So the area of the ace of diamonds divided by the total area of the sample space, divided by the probability of event 2, so just getting a red card. So the area of red card divided by the total area. So what's the probability of getting an ace of diamonds? Well, that's 1 out of 52 divided by the probability of getting a red card, which is there are 26 red cards out of a total of 52. Notice the 52 cancels, and we get 1 out of 26. And this equation right here is relatively useful. Doesn't seem useful right now, but later on we can use it to solve for the intersection. So, and that's actually what you use it for. Is actually solve for the intersection. So all this little line means is given that. So if we were asked what's the probability of getting a 4 given that it was an even, we say it's 1/3.